Hello everyone, welcome to the second part of our course of rotating equipment engineering, the fundamental of machinery equipment oil and gas industry. Part 2. What we are going to learn in this section is the pumps technology. We will discuss many aspects of the pumps. We will discuss the most important pump fundamentals, practical fundamentals, pump types and hydraulic coverage chart, and pump application and surfaces. We will go deeply in discussion of the pumps from different aspects. What is the flow and what is the head range and what is the main characteristics between and the main advantage and disadvantage between different pumps types, including dynamic type and positive displacement type. So let's start. What is a pump? As we know, pump is a machine that are used to increase the total energy or level of the liquid stream in order to raise or transport or compress the fluids. This is the main function of the pump. The pump is existing in different applications around us. The earliest pump were devices for raising the water, such as the Archimedes screw one. As we know that the heart is type of the pump. How the heart is working is positive displacement pump. And we'll discuss why the heart is positive displacement, not any other type of the pump. So pump is a device that moves the liquid by increasing the energy level of the liquid. There are many ways to accomplish this objective. The pumps are divided into distinct groups. One is by positive displacement, how to add energy to the fluid. Okay, so the main types is positive displacement and dynamic type. Positive displacement consists of reciprocating and rotary. The reciprocating one is including plunger type, piston, diaphragm. Depend on the element moving and in contact with the fluid. This element is that increasing or that deliver the energy, mechanical energy to the fluid, is either to be a plunger or piston or diaphragm. Then the rotary type is including a vane or gear or loop or screw or piston. And the dynamic type is depending on rotating blades. It's like a fan. Rotating blades, there is an impeller. An impeller consists of vanes. These vanes accelerating the flow. So the dynamic type is either to be centrifugal type, mixed flow, or axial flow. Depend on the outlet flow. The outlet flow is coming parallel to the axis of rotation, like axial flow, or getting out perpendicular axis of rotation in radial direction. This is called centrifugal type, or in between, like a mixed flow pump. Each type have different shape of impellers or the vanes or the aerofoil of the impeller, different shapes that become the fluid either to be axial or radial or in between. This is depending how you change the momentum of the fluid, how do you accelerate the fluid of momentum. As we know that the momentum of the fluid is mass and velocity. Mass times the velocity. And the velocity is a vector, and this vector is magnitude and direction. If you are going to change both magnitude and direction, this is centrifugal type. If you are going to change only the magnitude, not the direction, this is axial type. And if for sure each one have different characteristics, have different range of the flow and head, produced head. Okay, let's start with the positive displacement. Positive displacement pump is increasing the pressure by operating on a fixed volume. Fixed volume in confined space. Fixed volume means that delivered flow is always fixed. The flow rate is fixed, regardless the system resistance, regardless of the delivered pressure, regardless of the density, and as well as the viscosity. A little change. We will discuss this later. But it is delivering a fixed volume flow rate. the certain amount, fixed amount of the volume flow rate that doesn't change regardless the other operating condition changes. Regarding the system, it changes. There's a fixed amount of flow rate. And for sure, you have to be sure that the suction valve and charge valve installed on the pump are always open. When the pump is operating. You cannot make the valves partially open. No. You have to be sure that the valves are fully open, because there's a certain amount of flow has to get out. And if you make it partially open, or make it a little bit closed, so this means you increasing the pressure downstream the pump, or make a cavitation in upstream the pump. Okay. Second, the pump will displace the liquid regardless of its specific gravity and the viscosity, as long as there is a sufficient power is available from the pump driver. That means maybe the motor installed on the pump is overloaded and there is a short circuit, or there is a problem in the motor will fail before you reach a certain amount. We will discuss how we deal with this pump. The first type of the positive displacement pump is the reciprocating pump. Reciprocating type. This reciprocating type are those types of those displacement pumps that increase liquid energy by pulsating action. This is from the name of the pump. Reciprocating. This is sun wave. So there is a pulsating action. So the flow will be in pulsating action, and the pressure wave, the static pressure wave, will be in pulsating action. Our reciprocating pump produces pulsation, and this is characteristics of this pump, that can cause damage to the pump and or the process system if this is the main concept. If the system is not properly analyzed and designed. So you have to be careful when you design, not only you specify the pump and order the pump, but also you have to be careful about the system. How you optimize, how you design the system. I mean the piping system, all auxiliaries installed in the system, valves, and everything on the system, upstream the pump and downstream the pump. So it should be properly analyzed and designed. The anti-pulsation devices are usually requested. Yes, in the discharge of the pump, the charge side of the pump, one of the main devices must be installed in the charge of the pump is anti-pulsation devices, or what's called pulsation damper. Pulsation damper simply is a vessel, just a vessel. This vessel either to be empty vessel, or this vessel have a bladder that has be filled with nitrogen with a pressure about 70% or 80% of the operating pressure. That means that if the discharge pressure is 100 bar, so the discharge pulsation damper that installed in pulsation damper line have a bladder. This bladder will filling with nitrogen. The nitrogen pressure shall be 70 to 80 of the operating pressure. This means 70 to 80 of 100 bar. This means 70 bar or 80 bar is range. The third design is a pulsation damper. This vessel including just internals. All different ways to make a damping of this fluid fluctuation in pressure wave. So is must on the charge, and we'll discuss when it's mandatory on the suction as well. The second one is a plunger pump. Plunger pumps. So plunger pump. What is a plunger pump? Plunger pump is a reciprocating pump that the process fluid is in direct contact with the plunger, and is used for higher pressure application. This means that it gives a higher pressure than the reciprocating one, and usually the flow and the pressure are related. So if it give higher pressure than reciprocating, this means piston. ماشي. Plunger pump. Plunger pump is a reciprocating pump that the process fluid is in direct contact with the plunger and is used for a higher pressure application. As we will see, it's used for a higher pressure than the piston one and the diaphragm. So the most higher application of the pressure, that's mandated pressure, high pressure, is used a plunger one. And the pressure and the flow are related, so if it's give a higher pressure than the piston and the diaphragm, this will mean less flow than the reciprocating, the piston and the diaphragm. As we will see this later. The plunger pump. As we see, usually there is a suction valve and charge valve. This suction and charge valve is operating against spring force acting on the spring due to the pressure difference in the suction and also in the charge. So there is a valves in the suction and the charge. This is a plunger one. Piston pump. So instead of using a plunger to transfer this mechanical energy, plunger and diaphragm. So instead of using the plunger, use a larger bore diameter. It is called piston pump, and this is the same. The suction valve and charge valve is coming from suction and in contact with the piston and deliver the flow through the charge. Either single or double acting pump, both figures are used. The third type is the diaphragm pump. The most common used one is metering pump or diaphragm pump. This type of pump is most commonly used for chemical injection service and it's called for this application metering pump or controlled volume pump. When it's requested to precisely control the amount of the chemical injection or inhibitor being injected into the flowing process stream. This means that this type of pump, the diaphragm one, the fluid in contact with the diaphragm, just the diaphragm. This type of pump is delivering certain amount, precise amount of the flow. This means if it's operating at 100 liter per hour, it will not be 110, 120. No. It will not be 80, 90. No. It's very precise. Due to the need of the application of the chemical injection with a certain amount of the species and different species that deliver certain amount of each flow. This means that the other types of pumps mean the plunger one or piston or rotary pump, the flow rate change may be within more than 5% or 10%, 3%. But for this pump, no. This pump, the maximum change in the flow, acceptable change of the flow during the linearity test, during the breathability test of this pump is 3% as per API. The API used for this pump is API 675. Okay, volume control is provided by varying the effective stroke length. One of the characteristics of this pump is, as we have mentioned just before, that is all the reciprocating, all the diaphragm, the piston, or both of this piston pump is delivering certain amount of flow. This means there is no change in the volume flow rate. If you would like to change the volume flow rate, you have to use external device by operating at different speed or make a recycle line. But for the first time, this pump have a characteristics that you can deliver different flow rate. So you can change the stroke length, and the mechanism for this, we will see this mechanism that you online when pump is operating, you can change the effective stroke length. And if you change the stroke length, this means that the delivered flow that depend on the bore diameter and the speed and the stroke length, the delivered flow will be changed from 100 liter per hour, for example, to 10 liter per hour. From 100 liter per hour to 10 liter per hour. Yes, you can do it while the pump operating. And you can change the stroke length by different means, either manually, locally, or you can change it through motor, electric motor, or pneumatic actuator, and this can be done for sure remotely from the DCS or from the control room. Okay, the process fluid is isolated from the plunger. Where is the plunger? Yes, there is a plunger. Yes, the plunger is used to hydraulically actuate the diaphragm. So the mechanical action coming from the shaft, the motor shaft, through the gears, coming to the plunger, and the plunger is moving an oil, and this oil, due to it is incompressible, so the moving oil, by moving of the plunger, move the diaphragm in the suction side and the charge side. While the plunger is moved, go away, so either the oil also will move, and when the oil is moved, it will move the diaphragm as in suction and charge. So it is most likely this pump is hydraulically actuated pump. It's also called hydraulic actuated diaphragm. Hydraulic actuated diaphragm, due to the moving of the diaphragm, is by oil, and the oil is pressurized or moved by the plunger. The plunger is moved by the motor. Okay, it's used for lower flow application in terms of liter per hour. This is lower with respect to the plunger and with respect to the piston pump. Another characteristics of these pumps is where the escape of the pumped liquid to the atmosphere is not acceptable, due to you transfer hazard fluid, toxic fluid, flammable fluid, so you cannot rely on one diaphragm. Actually, they use two diaphragms. Diaphragm pumps can be provided with a double diaphragm with a leak detector to alarm on the failure or either diaphragm. So in case of toxic fluid or flammable fluid, if they used double diaphragm, and between two diaphragm there is a pressure transmitter. This pressure transmitter reading normally is 0. So if the diaphragm in contact with the process fluid is cutting due to something coming in the suction line, like solids, like anything, abrasives, anything, if it's cutting, so the pressure transmitter will read a certain amount of pressure, the discharge pressure, give you alarm that you have to take action by stopping the pump and replacing the two diaphragm by another set of diaphragm. So usually we order with this pump a set of diaphragm as a spare parts. Usually it's commissioning or 2 years spares. A set diaphragm. Okay. We will see a nice video. We'll watch another nice video for this pump, how it's operated. Another characteristic of this pump is that this pump has internal relief valve. One of the main characteristics of the positive displacement pump that is mandated, you have to install on the discharge line a relief valve, pressure relief valve, because this pump is not self-limiting. When you blockage it, when you wrongly close the discharge valve, the pump will go to continue to deliver the flow, so the pressure will increase. You make a break, piping, so you have to secure the system by installing a pressure relief valve. So only this pump type have internal relief valve that is not needed to install another one external relief valve. The internal relief valve will open if you close the discharge valve. If you close the discharge valve, so the pressure will increase, so the internal relief valve will open and relieve this pressure. And there is also the suction valve and discharge valves operating spring type operating against the forces. This is the plunger, and this is the oil diaphragm, and this is the diaphragm. So in moving the plunger, the oil is moved, then the diaphragm is moved, then the fluid is coming up and go down. Every type of the pumps have this one, real one, maybe have different more than one pump on one skid, on common skid. You see this is one skid, and this is 1, 2, 3 pumps. You can split the flow on 2 pumps or 3 pumps, depending on how much of the flow. So this is a suction, and this is a charge, and this is the diaphragm. This moves the plunger, and it's moving the fluid. One of the main characteristics of these pumps, and you have to be careful about the system of these pumps, is the pressure relief valve, the pulsation damper, and the pressure relief valve. On the discharge side, on the discharge piping of the pumps, you have to install shake valve. First is the shake valve, second pressure relief valve, third is a pulsation damper. So you have to install pressure relief valve and pulsation damper. And the pulsation damper and the pressure relief valve, especially the pressure relief valve, you have to install it just after the nozzle, discharge nozzle, just after the discharge nozzle. Any isolation valve have to become after. So the first device coming after the discharge of the pump is the pressure relief valve, the safety relief valve. Because if the operator has done something in mistake by closing any valve, by any something, so you protect the pump and protect the system by the safety relief valve that coming in first. And also pressure relief valve, besides the pressure relief valve, is a pulsation damper. Pulsation damper to damping the fluid and to save. What is the pulsation damper main function is to reduce fluctuation in the line, reduce the vibration in line.